All right, in this video, we're not going to show you the dimensions and how we calculated the dimensions for the giant Lego. We're just going to make a file that's going to be kind of our master file for all of our dimensions. So these dimensions, just understand that we've gone through the calculations to do this. I'll have another video that walks you through what we did in order to get these numbers. But for today, we're just going to make this file together. So this is where we start. We're going to build a file that we can then utilize for um, all of our subsequent files. So we're going to create some parameters inside of this. So the first one that we're going to use is Lego base, and that value is going to be 0.315 times scale. So we actually need to put a scale factor in here. Make sure that you make this unitless, and we're going to do a scale factor of 3, and then I'm going to go back and do a times scale on this for our Lego base. That looks good. We also have a stud diameter, and that's 0.192 times scale. And then we're going to have a partial height, and that is 0.125 times scale. We're going to have a full height, and that is partial height times 3 times scale. So partial height is the height of a single brick or a single plate. And we're just measuring these with a caliper. These are what we have found through our classroom measurement, that these are kind of the values that we came up with. Again, not every Lego is identical. They're all pretty close. They're injection molded, and it depends on um, where in that cycle of the mold. Depends on how tight that tolerance is. But for the past 40 years, Legos have, I can take Legos from 40 years ago and integrate them with new ones, and they fit just fine. Let's go with our next parameter. Let's see, we've got, we'll do stud height. Now this one, we did 0.066, but I really think it's 0.070. So I'm going to use that in this video. I think it's a little bit taller than what we have been doing before. It's not a huge deal on that. We're going to call hole depth. So these are the underside when we extrude up to capture the kind of the top of the stud. That's what this is. So we're going to use 90 thousandths for that. Now, some of you might be saying, why aren't we doing this in millimeters? Well, we're in the United States and we don't use millimeters a whole lot. We use, and most of our dial calipers aren't in millimeters, so that's why we're using inches. Legos are based on an 8mm block, but again, that comes out to about 0.315 when you're doing this. So again, our numbers are going to be a little unique, I guess. They don't look normal in terms of like, why would you pick this number? Well, it's based on millimeters, and if you were to base it on millimeters, then these would be like whole numbers, like 8 millimeters, 0.1 millimeter, 0.08 millimeters, those kind of things. We're going to create a thing called kerf. Now, this isn't really the technical name of it. We just call it this because when you use a laser or a saw and you cut material, it's going to remove extra material because of the thickness of the blade, which is the kerf. This is essentially like the air gap that goes around the part is what we're calling kerf. You could just call it air gap or just gap, but in laser terms, when you laser a, let's say a 1-inch square, because it's burning material, you're not going to get a 1-inch square out from the laser. It's going to be smaller than that because, again, it burned away material. So it's kind of like the kerf that's built into that process. So you have to account for it. The same thing is true for when you're making parts that have to assemble or press fit together, you can't make them the exact same size. There has to be a gap around the part for it to work. So we just call it curve. So these are our values. We might add some more later. Actually, we'll probably add, we'll call a small shaft, and that's a 0.125 times scale. And I think that's about it. Those are our main dimensions that we need, and we're going to use these parameters when we build out our parts here. So the first thing I'm going to do is I'm going to make a 1x2 so that I have some reference dimensions for the other parts that I make. So I'm going to just dimension this side over here. It's going to be Lego base, and then this side over here is going to be Lego base times 2. And that is the size of our Lego, but remember, we're going to remove material from the outside of both of these. So I'm going to go back and edit, and I'm going to say that it's minus 2 times curve, because on the outside we're removing material, a kerf on each side. And I'm going to do the same thing here, minus 2 times curve. And you'll notice that this side is not twice the length of this side, which is what you find out with Lego, is that the reason is because you have a 1x1 that sits about here, and then you have another 1x1 that sits here. And if I were to use the equal constraint to say this side is equal to this side, let's see if it'll let me grab. So this is what I don't like about, maybe I don't know the trick. How do you grab the smaller piece there? And then I'm going to grab the smaller piece. So I just kind of wiggle along until I find it. But there you go. Well, see, those are two 1x1s, and notice that they don't touch. There is this air gap between them that should be roughly 8 thousandths, which is essentially 2 sheets of paper. So if I were to dimension those 2 spots, you'll see that you've got an 8 thousandth gap between when you put 2 Lego pieces that are 1x1s on top of a 1x2. So that's why we talk about the kerf that goes, this air gap that's around every piece when they put together. And you can test this. You can put, a sheet of paper, fold it in half, and put it between 2 Lego bricks that are 1x1s, and the paper fits right in that gap between 2 1x1s sitting on a 1x2. So that's what we're doing, and that's why we're doing this process. I can get rid of those rectangles easily, so I'm just going to start over. Again, Lego base, enter, minus 2 times curve, enter, enter, and then I can do this one. I guess I should hit tab, but Lego base, enter, times 2, minus 2 times curve, enter, enter, and there we have our values. Construction lines are great. So I typed L for the hotkey for line, and then if you hit X, it will toggle it to a construction line. So you can see that toggle up there. That allows you to grab midpoint lines that you can use for reference. I can also grab, and make objects. And if I don't want them construction lines, I can just click on it and hit X, and it will toggle it back to a normal object line. The distance between these two is going to be Lego base, and then one of these is going to be stud diameter, is what we call this, and then we can make them equal to each other. And then I can use a symmetry constraint to make these two symmetrical about this. And you might be saying, well, why didn't you just dimension from one side to the other and say half of the Lego base? Well, remember, we removed a kerf from the outside and the kerf from the outside. So the distance to the midpoint to the center is different than the distance from here to the outside, because there's an air gap that sits in there. So we always try to do something that's symmetrical about the middle, because we've removed material from the outside of the part. So it's always going to be smaller distances from the outside than it is from the things that are in the middle. So just kind of keep that in mind when we're doing our references. And then for the underside, so this is the top side. These are what our dimensions should be when we measure the top side. Now for the underside, we're going to show what those dimensions should be. So most of these, we're going to make lines that are tangent to these studs because this is where the grip happens. So we're going to use the tangent constraint to make these lines tangent to these circles. And then we're going to do an offset of that line. So when I do an offset, I'm going to do kerf divided by 2 is what we have found for most pieces. Now I'm going to put that in there for most pieces because if you have at least 2 studs that you're gripping onto, this seems to work great. If you only have a 1 by 1, then we usually just do this as kerf. So it squeezes a little bit tighter. So you can see when I zoom in, here's the circle part of the stud that will insert up from the bottom. And this is the wall that's going to grab it when it inserts. So you can see it's going to press a little bit into that piece as it grips onto that part. So I put this here. Now, in most like 1 by 2s or any of the 1 bys that are long, you have this center. I don't know. It's not a center kind of column that sits in here that also grabs these edges. So we're going to show that. And to make that part, I'm going to make it a construction line and I'm going to make it tangent to this. And then I'm going to use the offset tool and I'm going to offset this by kerf times 5/4. So it's a little bit more than a kerf. It's actually going to come out to be 5 thousandths when we do this. So you can see that value is 5 thousandths. I like to put this up here, so if you're going to look for how did I find that dimension, you can double click on it. And then I also am going to just show what this dimension is so you can check it. So it should be 0.379, and it's a driven dimension because we've already dimensioned it to this. So it's saying, hey, this is going to change based on this. But that squeezes a little bit tighter in the middle when you have these parts, and that's what we found works really well. This is really all the dimensions you need now for your part. I'm going to show these last 2, which is this dimension, and again it's basically a driven dimension, which is fine, and we're going to do this one, the solid line, and show it. And the reason for this is now you have all the dimensions that you need for this part that you can check and be like, okay, what should that dimension be when I'm making the real deal? And you can use this as reference. And then I'm going to make another part. This one I'm going to make a 3 by 4. So that I have my 1 dimensions are over here, my 2 dimensions are here. This will be my 3 and 4 dimensions for this. So I'm going to bear with me on this. We're going to get this all set up. And then we'll probably make another video that starts, let's just do 1.5. So this dimension is just to create some spacing between those. All right, how tall should this be? Well, this should be Lego base times 3 minus 2 kerf. So that's how tall a 3 by should be. And then we go to this one. And this should be Lego base times 4 minus 2 kerf. So again, you only have air gaps on the outsides of the part. So that's why we're only taking off 2 of them. We don't put all the air gaps in the middle when we do this. Now we could show that if I put a 1 by 2 right here and another 1 by 2, that there's a 0.008 air gap between them, or we can just do some math. If you take this number, got my calculator here, take 3.772 and subtract off 2 times 1.882, you should get 0.008. So it checks out. We could also think of it this way. If you did a 1 by 2, a 1 by 2, and a 1 by 2 sitting right here, you should have 3 of them with an air gap here and an air gap here. So you'd have 0.008 there and 8 thousandths here. So you should have 16 thousandths difference between this number and 3 times this number. So if we tried that, 2.827 minus 3 times 0.937, I get 0.016. So I've got an air gap between the brick that's here, and then an air gap between the brick that's going to be here and here. And you got 8 thousandths between each one. So these are, we've done the testing of the numbers. I'll go through the math on how we came up with those numbers in a different video. But for now, just trust the process. This is what it is. Again, I'm going to use some construction lines. I'm going to put a line right down the middle. I'm going to put a line right down the middle here. And then I can think about how am I going to build this out. So I need 4 circles this way, and then I need 3 going in this direction. So what I usually do is I'm going to create my circle. My first one, I'm going to make this a regular line, and then I'm going to just say it's equal to this circle, and then I'm going to dimension it to this, and now this should be Lego base divided by 2, where that's at. And then I can do basically a rectangle pattern of this, and I can go top and bottom, and I can go left and right. So this is kind of the cool thing about rectangle pattern. So I'm going to do that. I'm going to rectangle pattern this, and so I can go up and down, or I can just say instead of one direction, I can say symmetric, and the distance I'm going to use is spacing, and the spacing between them is Lego base. And then I can go, see how I can do this? So I'm just going to go this way, but I only want 2 of them. And this is going to be negative Lego base. And you can see I can get all 6 of those right there. And then I can use my mirror function, and I can mirror all of these along this line. And now I have all of my circles there. And you should be able to do a dimension between these two. And what should that be? 0.945, which is my Lego base dimension. So it works out. Now, the underside of this. Very similar to what we did before. We're going to use a rectangle around the whole thing. We're going to tangent to each of these. And then we're going to offset by kerf divided by 2. That squeezes that in. Again, I can show this up here. And then I'm going to hit dimension, and I'm going to show these dimensions. This one right here. So when I'm checking my parts, these are the numbers I should have for the underside. Great. And now we're going to draw the circle that's in the middle of this thing for the underside. So if you look at your flat piece, you'll notice that there's a large circle that squeezes on the 4 of these. So I'm going to create my circle right at the midpoint here. It's going to be tangent to this. And I'm also going to create one because a stud actually inserts up into the middle of this. So this is going to be stud diameter, which I don't have to, I'm actually not going to dimension this. You're asking, you're saying, why not? Well, because I can use an equals constraint and say it's equal to this. And now what I want are some offsets to get some squeeze here. So I'm going to use an offset tool, make it so it's not construction. And I'm going to go out kerf. I think it's kerf. Let's see. It might be kerf times 5/4 again. I know what this number should be. It should be 0.77 is what we want. So let me dimension, not that one. I want to dimension the one that is this one. There we go. 0.77 is what that should be. Okay, so we did another kerf times 5/4 to get that number right there. So I'm just going to kind of pull this out. So if we ever need to reference it, it's right there. And then this one, we're doing an offset so that the stud can fit in there. If we make it the same size as the top of the stud, it's not going to fit. It won't press fit into there. Or if you press fit it in, it isn't coming out because it's too tight. So this one we're going to make kerf a little bit bigger, and you're like, well, why is it not kerf times 5/4? Well, again, this is just through testing. We want it to insert into there. We want it to stay. We don't want it to be sloppy in there, but we also want it to come out. So we're making it basically a little bit bigger. I think it's kerf. Let's see what we get. I think it should be point 582 maybe. Let's see. Okay, so I think it's supposed to be 0.582 is what the number is on my actual one. So we might have to shrink this up a little bit. So this, if it's not kerf, it might be kerf, might be kerf divided by 2. No. So it's going to be kerf times some fraction. So I think it's 3/4 on this one. We're going to leave it as 3/4, and this is where we might have to make an adjustment based on your 3D printer on these numbers. So wherever we did these offsets, the reason why I'm kind of leaving them out and open is you might have to make adjustments based on your 3D printer. So we're using PLA Plus for most of our parts, and we're using Bambu printers, which are pretty good at being consistent. But this is, like I said, this is where you're going to want to make adjustments. There are all of these little offsets based on your 3D printer. So we're going to get one of these rolling, and if you make 2 1x2s, and then see how they press together. If they're sloppy, if they rotate, like if you put them together and you hold them up and they rotate, if you just put a single stud in there, then you have to make some adjustments to these numbers. But this is where we're going to start. We need some kind of starting point, and then we'll make adjustments to offsets as you go on your printing journey. But this is it. This is our master file that we're going to be using. So when we save it, we'll call this our Lego master file. And now every part we make, we'll start with this Lego master file, and then we'll do a save as, and we'll make a new component. So looks like this is going to be a really long video, so we're going to stop right now. We're gonna pick up next time with actually making the bricks, but this video right here is the key to get started. How do you make your parts from scratch and have them ready to go for a 3X build? So stop watching and start making. We'll see you next time in the workshop.